Hello, Insulet team. My name is Luis Fernando Fragoso, and I am a candidate to the software trainee program at Insulet. Today, I would like to guide you towards a project that I developed while I was taking a course called Data Structures. Specifically, we studied data structures by using Java, and I felt very passionate to develop this extra activity. Like it wasn't mandatory to do it. However, I spent all my vacations, all my winter vacations on it. And yes, there are others programs that I developed as at college. But yes, I chose this one, bearing in mind that I've spent like much time on it. So, yes, let's take a look at it. Okay, so let's go over it. Well, this program is split into multiple documents. In this case, this specific document defines the graphic user interface, and this interface guides the user through the whole program. And this program, well, plus this program, has multiple functions. One of those is the function to create a binary tree with the data that the user provides to it. The user can enter multiple numbers, which have to be like integer numbers. They are not like more like float numbers. They have to be integer numbers. And yes, the user can type uh, multiple integers, and like taking all those integers, the program creates a binary tree. Then the program also has a function in which this algorithm max heap and min heap is used to create a whole list of students which are not who are not like real students. This program also merge strings in order to create like fake student numbers and fake student names with their um, last name and first name as well. So yes, I spent all my whole winter vacations on this, and yes, it was it was challenging to combine this algorithm with a real life application. So yes, we can take a look at it. It is all graphic. It's all graphic. It offers a graphic user interface, which is like more. I as far as I concern, it's like more understandable for the users to know what they have to do, what they should do within the program. And yeah, I've made this program probably like 3 years ago, and we also studied other topics. But yes, so let's go over it. Well, for this part, I designed the graphic user interface in order to display um, the course in which this program was made, which was data structures, and I also specified that we were going to use this heap sort algorithm for this application. So well, it's practically in Spanish. So it has two options. One, to exit, um, to exit the user from the program, and the other one is to go to the program, to the application. So yes, let's go to the application. Well, it also explains what the user has to do. It has to enter um, integers to an array, and then it the program makes a binary tree from it. Then we can apply the heap sort algorithm. And just like I was saying, the the user has to type um, multiple integers. And I also made a function um, in order to prevent the user to um, type characters that are not allowed to be in an integer array. Like if I type f, I'm typing f or ert, but it cannot be entered into this array. Be, bearing in mind that they are not integers, and there was a certain term to call this way to protect a program from for misutilization. Yeah, there was a professor who used to say that this is called um, like blindar a program. Well, yes. The thing is that it is not allowed. Well, the user is not allowed to enter characters that are not an integer, like a point. I'm typing point, and I type in enter, but this says favor de ingresar un dato. Please type an integer. And there are other things that I was very interested. So yes, I spent much time doing this. Well, yes, yeah, we can enter other integers like 7, um, 34, 21, 55, 9, 67, and yes, well, the user has the option to delete all the data from this integer matrix, or to delete a certain um, a, a certain integer from it. But we're gonna go through the next step. We can also like check if these how these functions work. I like honestly, I don't recall, but as far as I recall, yes, they work. But yes, let's go to the next step. So I'm gonna click. I'm gonna choose this option, which is to generate a complete binary tree. And this term, uh, I don't recall what was specifically a complete binary tree. There were certain requirements to call a binary tree a complete binary tree, and this is the contraction from this term, complete binary tree. I used to call it CBT, but yes, we can make it from this matrix. And this program explains like um, not graphically, but with like written, how is this complete binary tree made, how this complete binary tree was made. Yes, so it says like the complete binary tree, without applying heapify which is this is the algorithm that we call heap sort algorithm. So as we can see, the return of it is 23. Then the right sum of it is the integer 34, and his um, left sum is the 7 this integer, and so on. So this is the result from from it is the the simplest um, CVT, or complete binary tree. But if we apply this heap sort algorithm, we're gonna have a different result. Yes. Well, so let's see what happens. Well, then we have something different. There are two different like versions of this algorithm. The one called max heap and the other called min heap. So the thing that make it differ from each other is the way it is sorted. If we can see that if we apply this max heap algorithm, this variant from this heap sort algorithm, we're gonna have a different result. We're gonna have this this CBT, or complete binary tree, but sorted from the smallest integer to the greatest. On the other hand, if we apply this min heap version of the heap sort algorithm, we're gonna have a differently sorted um, result or matrix. We're gonna have like the opposite of the max heap sorted matrix. Yeah, and we can see this like in an applied in an applied problem by clicking into this uh, go to the app go to the app option. And well, it says that we should enter at least 30 students to make um, a matrix yes to make a matrix with fake student um, identifier numbers, their names, and also their there's a certain word in English, and it's very American. GPA. It also creates their GPA. So we have to enter here. I'm gonna enter 54 students. So as I was saying, I typed 54. It defines the amount of students that are gonna be created. And yes, well, so then we have to, or after this, we have to click into this option, which generates a complete binary tree. Okay, yes. So they are made. They are made. Yeah. As I mentioned before, this program creates um, their identification number, their GPA. These were their current courses, if I recall. Also, it creates yes, it creates or uh, it also can be called as it defines their major, and their name. I made this by using a simple data structure, which is called it is called like it is an array. Yes, it's certainly an array, but it is like flexible. It is not defined just to have um, a certain amount of data into it. It it can it vary, like it varia depending on the data um, that is stored into it. So yes, and randomly I made this program to choose randomly through all those options. So there were like uh, string arrays, and randomly they were merged with other um, with other strings from other array in order to create a whole name that has the first name, the middle name, and the last name as well. And yeah, um, we can count this, and we're gonna see that there are 54 students. Yeah, so they are not sorted. If we take a look at this, we can see that there's a guy with 7.9, with a 7.9 GPA in the scale of 0 to 10, which is different from the American notation. There's a guy with almost a 4.0 GPA, and so on. But by clicking into this button, we're gonna have this array sorted. Well, it's not just an array; it's a complete binary tree. And yes, we're gonna see the results. Tree. Okay, apply this. Okay, good, 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 good. So um, it defines the binary tree without applying the heap sort algorithm. And yes, the this program um, doesn't like show graphically the complete binary tree. It explains how the binary tree is created, like node by node, if they're like right nodes or left nodes. So now we can apply the heap sort algorithm, and we're gonna have a result, a different result from the thing that we got before. So yes, we're gonna take a look at the results. And first, we have the binary tree sorted with the mean heap, with this variant from the heap sort algorithm. And as we can see, the root of the tree is the guy who has a 0.4 zero, no, I mean 6.0 for GPA. That is the smallest GPA from this list. Yeah, and the last one has to be the greatest, uh, the greatest GPA. Yes. Well, we can see that difference in terms of the root. If we take a look at the tree that was sorted with this max heap algorithm, and yes, we can see this. We can see this. Okay, with max heap, and like on the contrary, or conversely, this max heap sorted tree root is the total opposite of the mean heap sorted tree. Yeah, yeah. This is totally different. Yeah, and like finally, we have the list sorted by using the mean heap algorithm, if I recall. So yes, yeah, this is the guy with the greatest GPA. Yeah, this Bruno Ivan Galan Filisol is the greatest with the guy with the greatest GPA. On the other hand, if we have this data sorted with max heap algorithm, we're gonna find out that the guy with the minimum with the smallest GPA is this person called Alison Mercedes Varela Bojayil, or whatever they're called. Yeah, and we can see that this data um, was rounded. It doesn't uh, shows like all the numbers in here. No, no. This rounds the GPA of this person in order to make it like more normalized. So yes, this is the program that I made, and additionally, we also studied other topics such as threats, uh, which are like multiple processes that are running at the same time. And yes, I'm really passionate to develop software, and this was a program that I made by myself. However, when I studied this, when I took a course on databases, I developed other systems. I developed one that manages a database from a cinema center, and we were able to make this CRUD create and update, delete, and uh, remove. I if I recall, but yes, the thing is that we also took like many other courses at college, not just ones that are related to software engineering, but also those that look on telecommunications. The reason is that my major combines two different fields: software engineering and telecommunications. But I am particularly interested into software engineering. And yes, I also participated in other programs, like the one called Reyes, which means Remote Experience for Young Engineers and Scientists. And I made a video for a professor from Washington. His name is Mike. No, 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 it's Michael. No, it's Doctor. It's Doctor During. His German, and I explained to it a program that I developed for a course that look on distributed systems. I developed a torrent in order to um, to allow the user to download songs, yes, songs or PDFs by using these I don't know how to say this, like by using this scheme of Leecher and Cedar. Yes, so there are many other things that I've done during all my academical journey, and I'm really passionate to collaborate, and I'm really passionate to get into this um, position.